quarter turn stairs with a landing. So again, we're going to do example number 1 that we did from the notes. Given info from the assignment or notes would be total rise of 9 foot 10 and a half. Upper construction there is 10 inches. Headroom is 6 foot 8. And then the landing was 38 by 38 for this example. Okay. So quarter turn stairs with the landing basically means that we have a landing, not necessarily in the middle, but then there's a change of direction, right? We're turning a quarter of a turn, so 90-degree corner. Typically, we're also given the distance from the top floor down, so a number of runs above the landing, for example. So if I were to kind of draw that out quickly, so in this example here, we're told that there's 2 runs above landing. Okay, so we're told that information. So if I'm kind of to draw that out, there's basically a run and then a second run, so 2 runs above a landing. So we're not really told which direction it's turning, but I'll just assume that it's going towards the left there. And then that staircase would kind of continue all the way down to the bottom. So this would be like an upwards direction here. Upwards direction to a landing, and then there's basically, like it says here, 2 runs above the landing. So if that's the landing, there's 2 runs, which then means there's 3 risers. That's a riser board, that's a riser board, and that's a riser board. Okay? So that would be given. So maybe the first thing we'll do is we'll go ahead and start with our math, getting the number of risers. So in this case, we don't have to worry about getting even number because we're not putting the landing midway. So we're going to take that total riser and divide by 7, and then we'll look at those numbers. So the total rise is 9 foot 10, so that's 108. So 118.5. That's 10 inches. 6 foot 8 is 80 inches. And then we're kind of good to go. So we'll plug that number in here, 118.5 divided by 7. 118.5 divided by 7 gives us 16 rises there. So we'll see what we get for a unit rise before we kind of continue. So we're going to take the 118.5 there, and then we're going to divide by the number of risers, which is 16. Right, so total rise divided by number of risers. So I'm just going to go times 7 to get my number back. Divide that by 16. So that gives us 7, that's not a bad number, 7.406, which is 7 and 6/16, but that's 5 or higher, so that makes that 7/16. So we're going to go with 7.4375. Forget about that number. So that's a good number. So the unit run would be 17.5 minus 7 and 7/16, which is going to give us 10 and 1/16. Okay, which is 10.0625. Step 4 there. We could do start looking at these numbers here. So step 4, we're told that there's 2 runs above landing. Okay, so that'll kind of be in your question there. So you kind of need to then realize that there's 3 risers below the landing, or sorry, 3 risers above the landing, which we kind of already looked at, right? So if there's 2 runs, there's 3 risers to get to the landing. Maybe step 5 there is getting the landing height. So we got to kind of look at what we just talked about. So we can almost finish this drawing off. We determined that there's 16 risers. So again, it's just a sketch, but it's a good visual. That means there's 15 runs. So we got 1, 2, 3. That counts as a run, right? So there's 1 here, 2, 3. There's 4, 5, 6. There's 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay? So we can kind of just continue that. That's 7, there's 8, 9, 10, 11, 12, 13, 14, 15. So we want to determine the height to that location, right? So one way we could look at that is see how many runs we have below the landing. So if we had, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we have 12 runs here to the landing, that means we have 13 risers. So if I want to find the height to the landing, I could just go, try to see if I get that to focus a bit better there. So if I have 13 risers to the landing, I can just go 13 times 7 and 7/16, and that'll give me the height at the landing. Another way I can look at that is if there's 16 risers total, there's 3 risers above the landing. So 16 risers minus 3 risers above the landing tells me that there's 13 risers below the landing. So a couple different ways we can kind of look at that. The drawing kind of gives you, again, confidence that you're correct. So if there's 12 runs, there's always going to be one more riser. These lines here represent risers, so I could count those as well. That's a riser. 1, count the lines, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? So I can kind of tackle that as well. So basically I'm looking at the number of risers below the landing. So the drawing could give me that. And I would multiply that by the unit rise. And that'll give me my landing height. So in this case, it's 13 risers multiplied by the unit rise of 7.4375. And that's going to give me the landing height. 13 times 7.4375. That gives me 96.6875. So 8 foot 0 and 11/16. Okay, so that's my landing height. Okay, next thing we want to do is determine the number stairwell opening. Right, next step is getting the stairwell opening. So to do that, I need to get the number of rises / runs in the opening. Like with any stairwell, that's kind of how we start that. So how do we get that? We take the headroom plus the upper construction, and then we divide that by the unit rise. So it's vertical divided by vertical to get the number of rises in the opening, which then is equal to the number of runs in the opening. So headroom, we're told, is 80. Upper construction is 10. And our unit rise is 7 and 7/16, so 7.4375. And we're going to go to 4 decimals. So we're going to go 90 divided by 7.4375. That gives us 12.1008 to 4 decimals, okay? From there, we got to kind of look at where is the, where does that end up, right? So we actually have 2 stairwell openings for a quarter turn stairs. We have a stairwell opening that's here, so we need this distance. But we also need a distance in this direction as well, okay? So we'll go ahead and find so we're going to call this one here the stairwell opening above the landing. So maybe we'll tackle that one first. Stairwell opening above landing. So again, I like to work off of these drawings here just to kind of make things a little bit easier. So if I wanted to find the distance from here to here, that's basically 2 times the unit run, right? So there's 2 runs. Each run is 10 and 1/16. So it's 2 times 10 and 1/16. That'll give me the distance from here to here. Then I have my landing size. So my landing size, we're told, is 38 inches. So I'd have to go plus 38 inches. And then we allow room for shimming there, so we'll go plus 3. So that's basically my formula. If I wanted to write a formula down to kind of memorize, which I'm a big believer in kind of working off of a drawing, but if I wanted to memorize the formula, I could say the number of runs above landing and I would take that number and multiply it by the unit run. And then from there I'd have to add on the landing, and then add on 3 inches. So kind of, it's exactly what we have here, right? So it's 2 times 10.0625. So memorizing, in my opinion, doesn't always work. I like to work off of a drawing, so it's long-term memory, right? So either way, so the reason why we're going 2 is because there's 2 treads, and we're multiplied by the unit run, which is 10 and a 16th, which gives us the distance from here to here. And then we'll go ahead and add on the 38, and then we'll go ahead and add on the 3 inches. And that's going to give us our stairwell opening above the landing. So 2 times 10.0625, and then plus 38 plus 3, so 61.2125, so which is 5 foot 1 and an eighth. So the distance from here to here is 5 foot 1 and an eighth. So now we know the stairwell opening above the landing. Right, stairs are going up that direction. Now step 8 there, we'll be getting the stairwell opening below the landing. So that's where I got to use the number of rises or runs in the opening, which is right here. So there's 12.1008 runs in the opening. So we have 1 here, we have 2 here, and we have 3 here. So if we kind of keep on going, there's 4. We got to get to 12.1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then it's 0.1. So it's about right there. That's where the stairwell opening is going to end. Right? So it's going to end right at that location right there. So the distance from here to here now is our stairwell opening below the landing. So we can kind of break up that the same way as we kind of just did. The distance from here to here is dealing with unit runs. The distance from here to here is dealing with the landing size. The landing size there is 38. And then we always add the 3 inches there for play. Okay? So this first half, there's basically, I kind of like to count them out just to avoid doing math. But 1, 2, 3, 4, 5, 6, 7, 8, 9 point. And so that's basically what it is there. It's 9.1008 runs multiplied by 10, so basically by the unit run. Unit run is 10 and a 16th, so 10.0625. So that times that gives me the distance from here to here, plus I add on the 38, plus I add on 3. There's my formula, my answer. So again, some people like the words there, so what we could use is basically number of runs in opening minus runs used in upper stairwell opening, okay? And then from there we'd multiply that by the unit run. Put another bracket on that, and then we'd add on the landing, and then add on 3. So again, I'm not a big fan of these formulas because it's something I got to remember. Where me a picture is visual, like I remember that picture, it kind of makes more sense to me. So whatever way works for you, but basically what's happening here is we take that number, which is 12.1008 runs in the opening, and how many did we use? We used 1, 2, 3. So you got to include that tread in there as well. So we actually remove 3, right? So if there's 2 runs above the opening, you have to include the landing. So 3. And then from there, we just put the brackets on that, multiply that by the unit run, which is 10.0625. Put brackets on that. The landing is 38. And then 3 inches. So if I kind of, you see I have the 9 there, well 12 minus 3 is going to give me 9.1008. But this 3 here is usually that adds a lot of confusion, that 3. Why is it a 3, right? Where there's no confusion. it's bang on every time. So I like the drawing way of getting my formula, but this works as well. But like I said, if there's 2 runs above the landing, we always have to make sure we include the landing. So there's 2 runs, but that's also a run, okay? So we have to include that. We'll times that by 10.0625. Add on the 38, add on the 3, and then there we go. So I'm going to go 9.1008 times 10.0625 plus 38 plus 3. So I end up with 132.5768, which is basically 11 foot 0 and 9/16. Okay. And I think that's it, eh? We maybe find the angle there, but maybe find the angle right here if you want there. So look at the angle, we take the inverse tan of the unit rise. So 7.4375 over the unit run, 10.0625. So use the numbers that would be on the framing square because that's what we're actually going to have. Then I just go make sure my calculator's in degrees, go second function tan, open the brackets, 7.4375 divided by 10.0625, close the brackets, press equals, and then there's my angle. So 36 point, I'm going to go to 2 decimals there, so 47 degrees. Okay.